All right, so we've already talked about the atomic number. All right, let's write it up again. Atomic number, which is also equal to the number of protons, which is the identity of the element, which if you look at a symbol, here's carbon, you have a 6 above it, it's that number right there. All right, let's now talk about mass number and isotopes. Okay, let's first talk about the mass number. Okay, the mass number, and remember the atomic number is donated by, or is shown by a Z, a mass number is shown by A. The mass number is a whole number, which equals the number of protons plus the number of neutrons. Okay, it's the total number of both of them in there. Okay, so for example, carbon, all right, carbon, in nature there are three different types of carbon. There's what's called a carbon-12. It has a mass number of 12. Another carbon has a mass number of 13, and another carbon has a mass number of 14. And these are the masses. Like if I were to weigh it, it would weigh 12 grams. If I weighed this, it would weigh 13 grams. If I weighed this, it would weigh 14 grams. Okay, so what are these? Well, if this is carbon, first of all, how many protons are in carbon? 6. How do I know? Atomic number. It's carbon. It always has 6. Well, how many neutrons are there? Well, if the mass number is 12, there must be 6 neutrons. Okay, because 6 plus 6 equals 12. Your protons plus your neutrons equal the mass number. Okay, this is carbon-13. How many protons are in carbon-13? All right, hopefully you said 6. If you said 7, you are thinking of the number of neutrons, not the number of protons. Protons never changes. Why does it never change? Because we're talking about carbon. Carbon has 6 protons, end of story. This has a mass of 14. It weighs more than all of them. So how am I gaining mass? I'm gaining mass because I'm adding more neutrons to it, not more protons. If I were to add a proton, let's say I had 7 protons and 8 neutrons, what would I have? Look on your periodic table. All right. So hopefully you said nitrogen, and what would the mass number be? You would say 15. Nitrogen 15 is 7 protons and 8 neutrons. How do I know? Well, 7 protons is nitrogen. 7 plus 8 is 15. Okay, so make sure you understand this. Okay, the difference between mass number and atomic number and the differences. All right, so what's isotope? These are isotopes of each other. All 3 of them are carbon, but they aren't exactly the same form of carbon. You remember Dalton said that atoms from the same element are identical? Well, that's not true. They're identical in the number of protons, but they are not identical in what? Hopefully you said the neutrons. I asked you that question as if I can actually hear you. All right, but I'm kind of testing you because hopefully I want you to be thinking about this. Okay, so protons are all the same, 6, 6, 6. Why? Because we're talking about carbon. Neutrons are different because the masses are different, because I have 3 different isotopes of carbon. Now, I do not expect you to know all the isotopes of any of the atoms. I'm just using carbon as an example. In fact, I only know a handful. I only know a few. Like chlorine, there are 2 different isotopes of chlorine. There's a 35, chlorine 35, and chlorine 37. Okay. So those are kind of the only ones that I kind of know. I think bromine has 2 of them as well. But you can go online and check out how many different isotopes there are for each element. Okay, so an isotope is the same element, but different number of protons. Same element, different. Remember, if it's the same element, that means you have the same number of protons, right? So you don't really have to say that. Same element, different number of neutrons. That is an isotope. Okay? So the way that you write this, so let's say we are writing carbon. Okay, and the way you kind of show this, here's kind of a way to show it, is you first show the mass number on top, so if we're talking about carbon-12, and the atomic number underneath. That's kind of the way that you would show carbon-12. So at last slide I showed you carbon-12. That's another way of doing it. But you can do it here. So carbon-13, why don't you draw out what carbon-13 should look like? I'll give you 5 seconds. So it's carbon, the mass is 13, and the atomic number is 6. Carbon 14 will look like that. How about that nitrogen, what was it, nitrogen 15? What would nitrogen 15 look like? Nitrogen 15, and what should go down here? Hopefully you put a 7, because nitrogen has an atomic number of 7. Okay, so atomic number here, mass number here, element here. How I remembered this, the mass number is always larger than your atomic number. So always put the larger number first and then the smaller number underneath it. That's kind of a way to remember it. I think a good way, a quick, easy way to do it. All right, this is just kind of showing you what I showed you about carbon, but these are different isotopes of hydrogen. There are 3 different isotopes of hydrogen, okay? One is the most common one, which is called hydrogen, all right? You have atomic number 1, that's the atomic number, which is the number of protons, and it has a mass of 1, okay? So the mass number is 1, and you have 1 proton. So how many neutrons are in hydrogen? The answer is 0. Hydrogen is the only element that has 0 neutrons. Pretty cool, huh? See that? 0 neutrons. All hydrogen is 1 electron and 1 proton. That is it. That's all hydrogen is. That's kind of why it's different. It's the only thing that doesn't have neutrons. This is a different isotope of hydrogen called deuterium. All right? This has a neutron. So it's atomic mass 2 because we've added a neutron to it. So we have like a hydrogen 1, we have a hydrogen 2, and then here we have a hydrogen 3. This has 1 proton. How do I know it's 1 proton? Because it's hydrogen. So 1 plus 1, which is 1 neutron, is deuterium. Tritium, which you kind of get when you do at like a nuclear power plant or an atomic bomb, you kind of get these free floating neutrons and they start going into water molecules, and that's how you kind of make tritium. It's kind of a radioactive form of hydrogen. All right, this has 1 proton. Why is it 1 proton? Because it's hydrogen. That's not what that 1 means. Plus 2 neutrons gives you a total of 3. Okay, so this is just kind of showing you the 3 different isotopes of hydrogen. Okay, here are kind of sample problems. Let's kind of do a sample problem real quick so we can do this. Determine the numbers of protons, neutrons, and electrons. Okay, so we have a chlorine. First of all, let's do protons for chlorine. How many protons does chlorine have? You don't even have to look at your periodic table because the answer is right there. That's the atomic number. So 17 protons. How many neutrons? Well, the mass number is 35. So you're doing 35 minus 17. Okay, so I will give you a second to figure that out if you'd like, unless you can do it in your head pretty good. 35 minus 17, you should get 18. So that is 18 neutrons. Okay, now electrons. We didn't really talk about this, but all of these species are neutral. We're going to assume that they're all neutral. Why do we assume that? If it wasn't neutral, there would be a charge up here. Like you would have a Cl with like a -1 charge, or like a potassium with a +1 charge. Okay, since I do not have charges, we're going to assume that these are all neutral. So if they're neutral, 0 charge, if you have 17 protons, how many electrons should you have? You should have 17 electrons. These have to balance each other out. Okay? All right, let's do the next one. This time they don't give you the atomic number, but you already know what the atomic number is of chlorine. It's actually right over here, it's 17. So how many protons is in that chlorine? 17 protons. All right, 37 is the mass number, so how many neutrons? You should have 20. Right? Because 20 plus 17 is 37. How many electrons? You should also have 17 electrons because it's neutral. If I had a charge up here, then you would have a charge. All right, I'm going to change this next one. I'm going to change this to potassium +1. Okay? I want you to put this on pause, and I would like you to do this problem. And when you come back, I will answer it. Okay? So put it on pause. 3, 2, 1, now. All right, welcome back. Let's see how you did. Okay, if you didn't put on pause and do it. Let me erase this for right now so we have room. Okay, so all I'm given here is the mass number, the mass of potassium. I need to find this number. That number is the atomic number, okay, for potassium is 19. So that number right there should be 19, which is also the number of protons. So protons equal 19. okay? And then I have this 41. All right, remember the 41 is the combination of my protons plus my neutrons. Okay, so my protons is 19, my neutrons is what I'm trying to find for a total number of 41. So if you do the math, you should get 22. So you should have 22 neutrons. 19 protons, 22 neutrons. Now let's talk about the number of electrons. Okay, in a neutral atom, I would have 19 positives and 19 negatives for an overall of 0. However, I have a +1. So what does that mean? Does that mean I have more positives, or does that mean I have less negatives? Well, if I were to do 20 protons and 19 electrons, I would have a +1 charge. However, 20 protons would imply what? That I have changed the element. We are no longer talking about potassium, we'd be talking about calcium. So I cannot add the number of protons and just say I have 19 electrons. This is incorrect. Charges, this is very important, the charge comes from the change in electrons only, not the change in protons. So if I have a +1, that means I have 19 protons, but how many electrons do I have? I must only have 18 electrons. These 18 negatives cancel out with 18 of these, leaving one more +1. So the answer is 18 electrons. 18 electrons, 22 neutrons, 19 protons. Okay, hopefully this made sense. If it doesn't, again, we will talk more about it in class. And I believe we might have some more problems with that later on. We'll see. Okay, so let's put this on pause. And what I would suggest is at this point, you might want to go and start doing some of your homework. All right, just go through the book, especially in section 1.6, where they have a bunch of these problems, and start practicing a few of these problems so that you kind of have a better understanding on how to calculate your atomic mass, your charges, all right, atomic number, and your number of protons.